equations with no solutions, or infinitely many solutions. As we have been working within this unit, we have only come across equations that have one solution. This means that there is only one possible value that could be true for our unknown to make our equation true. Let's take a look at this example. How many solutions does x plus 3 equals 2x minus 18 have? Now, this is an equation where there are variables on both sides of the equation. And as a reminder, if you see a variable such as x with no number in front of it, that means that it has a coefficient of 1. X is equivalent to 1x. To collect like terms, we are going to move all of our variable terms to the left side of the equation and all of our constant terms, or just our numbers that are alone, to the other. To undo 2x from the right, we must subtract 2x from itself. Whatever you do to one side, you must perform to the other. And 1x taking 2x's away has a value of negative 1x's remaining. We're going to bring down our adding 3, and we're going to bring down our negative 18. Now that we've collected all of our x terms to one side, we're now going to have to collect all our constant terms to the other. To undo positive 3 or plus 3, we must subtract 3. The inverse of addition is subtraction. Whatever you do to one side, you must do to the other. Negative 18 minus 3 is a greater negative of negative 21. Now, we're not finished solving because x is not isolated, or it's not positive 1x. Negative 1 and x are connected by multiplication. To undo multiplication, we must perform division. Therefore, we will be dividing both sides by negative 1, in which x has a value of positive 21. Now, before we begin, I did remind you that we've only been working with equations that have one solution. So how many solutions does this equation have? This only has one solution, and that one solution is 21. So let's take a look at what is true when you solve an equation and there is only one value that can be true for x. 21 is the only value that can make this equation a true statement, so there is one solution. Now, going back to the title of this lesson, there are times where equations can have no possible solution or infinitely many solutions. This means that every single number could be true for x. Let's take a look at this next example. How many solutions does 4x plus 8 equals 1/10 of x plus 3 and 9/10 of x have? Even though we're working with decimals within the equation, we're still solving this equation the same way. But before we can begin to collect like terms, I see that on the right side of the equation, we have 1/10 of x and 3/9 of x. That means that there are like terms, and when like terms are together on the same side of the equation, we can put them together. So combining our like terms, 1/10 plus 3 and 9/10 is equal to 4 whole x's. So when we rewrite our equation, we did not touch the left-hand side, so you're going to see that brought down. And we've combined our x terms on the right as 4x, bringing down our 3. When you see an equation that has something such as 4x's on the left and 4x's on the right, However, you have 4x plus 8 on the left, and then 4x plus 3 on the right. That's not balanced. When you see an equation in this form, where the coefficients are the same and the constants are different, this is alarming, and we know right then and there that this could never be a true statement. 4x plus 8 could never be equal to 4x plus 3. It wouldn't be balanced. And let's continue solving for x to show you why that equation could never be true. If we continue to collect like terms, let's move all of our x terms to the left-hand side. LOL, getting our letters on the left. To undo positive 4x, we would have to subtract 4x. Whatever you do to one side, you do to the other. And in this case, the x's on the right are eliminated, but the x's on the left are also eliminated. And you are left with a statement of just 8 equals 3, which we've already said is never going to be true. This shows that there is no value for x, so there's nothing that we can plug in for x that can make that equation a true statement. When you come to a conclusion of a not true statement, there is no solution. This means I could never plug a number in for x on the left and the right-hand side, and it ever becomes balanced. Now that we've looked at an equation with one solution, we've looked at an equation with no solution, now we're going to take a look at an equation that could have infinitely many solutions. How many solutions does 3x plus 15 equals 2x plus 10 plus x plus 5 have? Now, even when I was reading that out loud, the right-hand side of that equation sounds like a run-on statement because I have a 2x and an x, a 10 and a 5. So right away, we know that before we can solve for x, we need to combine like terms. Once again, if you have x, that's equivalent to 1x. 2x's plus 1x is a total of 3x's. 10 and 5 is a total of 15. Right away, I know that this statement will always be true, okay? Because if the left and the right-hand side are identical, I can truly plug any number in for x and it will always work. This means that there's not one solution for x. There's an infinite amount of solutions, and infinite means going on and on forever. However, let me continue to prove this to you. Let's collect our like terms or move all of our letters onto the left and all of our numbers onto the right. To undo 3x, which you can also think of similar to a positive 3x, we're going to take 3x away. And whatever we do to one side, we do to the other. And both sides, now the x's are actually eliminated from both sides of the equation. So all that's remaining on the left side is 15, and all that's remaining on the left side is 15. 15 equals 15 is always a true statement. So once again, every possible number you could think of can make this equation true. So therefore, there are infinitely many solutions.